You've officially made it to the last section this week, and we're going to look at expressions, functions, and equations of the form ax squared plus bx plus c, and factoring trinomials of the same form when a equals 1. Now, it's easy to lose track of what we're doing here, but just remember, whenever you're looking at quadratics or cubics or quartics, quintics, all this stuff, terms of degree 2 or more, you are looking for where those polynomials cross the x-axis. And there's a lot of different ways to find the answers. So here, let's go. We have some tips for you here. If necessary, rewrite the trinomial in descending order. If a common factor exists, factor it out. Find a pair of factors that have c as their product and b as their sum. If c is positive, its factors will have the same sign as b. If c is negative, one factor will be positive and the other will be negative. Select the factors that have the factor with the largest absolute value, and that's the factor with the same sign as b. And I've shown you this in some examples previously, but just as kind of a refresher. Check the results by multiplying the binomials. So you can always check to see if you found the right answers by doing that. We have a trinomial x squared plus 8x plus 12. I'm going to set up some parentheses. I know that x times x will give me an x squared, and I need to think of some different ways I can get 12. Well, I have 2 and 6. I could also do 3 and 4. And 2 and 6 actually works because if I multiply them, I get 12, and if I add them, I get 8. Since everything is positive here, we have a plus and a plus inside, that means that my two binomials are also going to have positive second terms. Let's try this next one in the row. We have 2a squared minus 16a plus 32. Remember to always check for a common factor first, which this has. Once I factor out a 2, I'm left with a squared minus 8a plus 16. So I'll set up my two sets of parentheses. I'll have an a and an a as my first term in the binomial factors. And then I need something that multiplies to 16 and adds to negative 8. So I'm going to try a negative 4 and a negative 4. And that works. Let's look at the next row. We have x squared minus 8x plus 12. Now see how that compares with the one directly above it. We had x squared plus 8x plus 12. Now we have x squared minus 8x plus 12. And so will we have the same answer? Well, in this case, we'll have an x and an x. We still need the numbers to add up to a total of 8, but they need to be negative now instead of positive. So we'll just say negative 2 and negative 6. Notice that negative 2 times negative 6 also gives you positive 12, but when you add the two middle terms together, you will get negative 8. Now let's look at the next trinomial in the row. I'm going to factor out the 5 as the common factor. We're left with y squared plus 8y plus 7 inside parentheses. Now I'm going to factor the trinomial. I know I need two y's as my leading terms in the binomials for the y squared, and 7 is prime, meaning the only numbers that will multiply to 7 are 1 and itself. Therefore, I have to have 1 and 7 as my factors. Since all three terms are positive, both binomials will have a plus sign in the middle. The next trinomial I need to factor is x squared minus 6x minus 27. I'll set up my parenthesis sets. I have an x and an x to make my x squared, and I need something that multiplies to negative 27 but adds to negative 6. Now if I think of 27, I know that have 9 and 3 will give me 27. 9 is negative and 3 is positive. And if I have a negative 9 times a positive 3, I will also get a negative 27 when I multiply FOIL. So that one's good. Let's look at the next one. I have p to the fourth plus 80p to the third plus 79p squared, and I need to factor out a common p squared out of all three terms. This will give me p squared plus 80p plus 79. Now that might look scary at first, but notice that the middle term is only one digit different than the last term. That means that 79 times 1 will give you 79. And if you add 79 to 1, you get 80. So that makes it pretty easy. We just replace the first space with p's. And since all three terms are positive, we know that our signs on the binomials will be positive as well. So 79 and 1. Let's look at the next row. Notice that the t squared minus 15 minus 2t is not in descending order of exponents. So I'm going to rewrite it as t squared minus 2t minus 15. I can now factor it. I'll have a t and a t, and a 3 and a 5 would give me 15. And so now I need to figure out which number needs to be negative and which one needs to be positive. Because remember, opposite signs multiply to a negative. They also need to add to something that is negative. So my smaller number must be positive and my bigger number must be negative. We have y to the fourth plus 5y to the third minus 84y to the second. My common factor is y to the second, and when I factor out y to the second, I get y to the second plus 5y minus 84. So I need to think about 84 itself. 2 times 42 will give me 84, and 2 times 21 would give me 42. Let's see, we would have a 3 and a 7 would give me 21. And so what I'm doing is I'm prime factoring. I'm making myself a factor tree, and I need to see if there's a way to regroup my factors to make 84 so that when I multiply them, I still know they'll multiply to get a product of 84, but they will add to 5. So let's look at 3 and 2 and 2 and 7. Will that do what I need? That would be a 6 and 14. 6 versus 14 will not give me a difference of 5. So I need to rethink what numbers I need to rearrange. So what about if I were to combine the 2's together? Those 2's would be 4. So I know that 4 times 3 times 7 will give me 84. So let's see if I were to multiply the 4 and the 3 together. That would be 12. Let's compare that with 7. That does give me a difference of 5. So my factors for this last trinomial are going to be y and 12 and y and 7. And my signs in between have to be positive for the larger number and negative for the smaller number. Don't forget to drop your y squared down front.